Now we'll be moving to subchapter 5.4, which is two force members and three force members. Yeah. So the solution to some equilibrium problems can be simplified. So that's the purpose of studying this particular subchapter. If we recognize the members that are subjected to forces, which is only 2 points. Okay. If we apply the equation of equilibrium to such members, we can quickly determine that the resultant forces A and B must be equal in magnitude and act in opposite direction along the line joining A and B. So let's look at this member here. Yeah, a member here, and then we have force B and force A. Okay, so what you can do is actually, because you can actually equate the forces. Yeah, equating FA equals to FB, you can put them and force them along one line. And this is two force members. Yeah, and then we're going to move on to examples of two force members. Yeah, let's look at the example before we move on to three force members. So can you see this link here? Yeah, you have seen this link before. And then this is like a backhoe, and then you have this, which is also a mechanical part of a tractor. Yeah, or okay, so this also can be simplified. So these are the applications of two force members. Okay. Now solving for 2D problems. Okay, before that I need to show you three force member. They didn't. Oh, in the slides they didn't. Okay. Anyway, before I proceed, let's go into three force member. Yeah. I'm going to go to the textbook. So two force member we have covered. Now let's look at three force member. This is rather unique. Yeah. I'm going to enlarge this. And I'm going to show a three force member. Yeah. If a member is subjected to only three forces, only three forces means in that system that you are looking at, you only have three force members. I'm trying to use the highlighter, but for some reason, okay. Only subjected to three force members. So it is called three force members. Okay. Example, look at here. The boom and the bucket. Lift is a three force member. Can you see? You have boom and the bucket. So this is a three force member. Yeah. Moment equilibrium can be satisfied only if the three forces are concurrent or parallel forces to the system. To illustrate, consider the member subjected to three forces like F1, F2, F3. Can you see this diagram down here? Yeah. So if you have force like F1, F2, F3, you can actually combine them to the intersection of 0. And then the line action of F3 must also pass through the point 0 so that the forces satisfy M0 equals to 0. Moment at 0 equals to 0. As a special case, if the three forces are parallel, if they are parallel, the location of the point of intersection O approach infinity. Yeah, of course, you don't have anywhere, right, to join because these are all parallel lines. So they will be infinity. Yeah. Let me just go through an example for you to understand so that your understanding gets better. Yeah, in this. So this is a very good example covering both the two force and three force member. Oh yeah. Before I forget, let's look at steps for solving 2D equilibrium problems. So what is the first step? You establish your coordinate. You call this as positive. You call this as positive. That's it. Then draw your free body diagram. Then you apply your equation of equilibrium. What is that? Your Fx equals to 0. Your Fy equals to 0. And then your moment. Which part you want to take 0? 0 or A or B, that's depending on you where you want to take it 0, depending on the question. Yeah, so these are the steps involved. Okay, and if there are more unknowns, than the numbers of independent equation, then you have the statically indeterminate situation. We cannot solve this problem just using statics in order in which we apply the equation that may affect the simplicity of the solution. For example, if we have two unknowns, vertical forces and one unknown horizontal, then you're solving Fx first, okay, which will actually help you to solve the unknown quickly. Always go for that. Yeah. If the answer becomes negative, do not panic. It means the direction that you have taken is upside down. Yeah, it's wrong. So it's okay. Your answer is not wrong. You just have to report the negative answer. Okay, so now I'm going to move on to the example, and I'm going to skip the examples that's in the lecture note. Yeah. Okay, this will cover next one. So we're going to go to the example 5.13 from your textbook. Let's look at this. The lever ABC is supported at point A. Okay, and is connected by a short link. So this is a short link. BD. If the weight of the member is negligible, so they said forget about the weight, so you don't have to draw the weight. Yeah, determine the force pin on lever A. So you need to find the force here on lever A. Okay, so how do you go about it? Okay, let's see. Okay, first thing to do is to go for the simplest thing. Yeah, you draw your two force member. So when you draw your two force member, can you see this is a pin, this is a pin? Yeah, so which means there is an F here, there's an F here, so they are connected 45 degrees. How do you know it's 45? 0.2, 0.2, so it is 45. Yeah, you have to be very quick. This is perpendicular, half of it, balance of it is 90 degrees, divided by 2, 45. So that's settled. Okay, next would be to draw the next part, which is the three force member. If you look at here, there is one force here. Of course, there is another force here coming here, and there is another force here. So you join all three. Remember what I told you just now? You try to join all three, connecting to a point. Okay, so you have done that. You can just take the ruler and just draw freely. Yeah, freely. Okay, now we have to solve. Okay, 400 we know already. Yeah, how's the distance? Distance, why? Okay, let me see. Okay, we have the distance of 1 here. Okay, 0.1. Okay, let me just think here. Okay, the angle here is 45. Yeah, the angle there is 45. What else is given? The length here is 0.5 given. The length here is 0.2 given. Okay, so we have 0.7, the total. 45, 45, and this will be 45. This angle we don't know, right? Okay, length here is given 0.1. Okay, and because of this 45, you have this as 0.5 because this is forming a triangle. Can you see this? This is a triangle. Yeah, so that's the reason this is, if this is 45, this is 0.5, and this is going to be 0.5. Okay, this is trigonometry. Yeah, in statics you have to be very, very quick with your trigonometry. So now you know what is the angle. I repeat, this is 45. 45 from the previous one, distance 0.2, distance 0.5 given in the question. Okay, and then we have the 400, leave that alone. So this is a question mark, we don't know. Okay, put that aside. So if this is 45, this would be 45. Remember the Z in your trigonometry. Yeah, so if this is 45, what happens? I repeat again, this triangle, if the length here is 0.5, this automatically becomes 0.5. Okay, you have filled up the blanks. So this is 0.1 and this will be 0.4, of course, because this is 0.5 here, minus, yeah? Okay, settle. Now let's solve the angle. Okay, so you're ready, pay attention. We're going to use a bit of trigonometry here. Okay, we want this angle, right? Okay, what do we have here? Let me see. We have 0.7 at the y-axis and 0.7. Yeah, wait, angle here 0.7. Yeah, the height is 0.7 and we have 0.4 in this axis. Yeah, so which means 0.7 divided by 0.4, the angle here will be 60.3. Okay, the angle is 60.3. So we have solved the first part. That's the most important part because later we're going to resolve the fx and fy based on the angle. So what we have here, we have fa unknown, 400 is given, here is unknown also. Yeah, we don't know. Yeah, okay, let's solve the thing. Fx, so what are the forces in x direction? We have the 400 and we have fa, which can be resolved into this position. Yes, slipping position, into the horizontal position, sorry, which is positive, fa cos 60.3, and then we have this which is pointing in the negative direction this side, so f cos 45, so you have equals to 0. Okay, next part, your fy, this got nothing to do with fy because it's horizontal. This, yes, pointing downward, negative sine 45, and this be pointing upward because of FA, yeah? Pointing upward. So what we have here, FA sine 60.3. Yeah, when you solve everything simultaneously, you will get your FA and your F value here. So this is how you solve for your unknown. So this is exactly using 2 force member and 3 force member example. So with that, if you have any question, you meet me during the consultation hours. Otherwise, you can just solve all the examples that I have asked you to solve and upload. So, and we will meet again in the next video. Yeah.